So if 50 grams of iron at 115 degrees Celsius is dropped into 100 grams of water at 25 Celsius, what is our final temperature? So in the last problem we had one substance, iron. In this problem we have two substances, water and iron. Whenever you get stuck with a problem, draw yourself a picture. So I have a beaker. And in that beaker I have 100 grams of water. So my mass of water is 100 grams. The initial temperature of the water is 25 Celsius. We are trying to find the final temperature, and the specific heat of water we can look up. It is 4.184 joules per gram degrees Celsius. I got that from your book or your appendices. Yep, Peter.
How do you know which thing you're finding the final temperature for?
It will be the same. So I've got this water. I drop my metal in. The metal is 50 grams. The initial temperature of the metal is 115 degrees Celsius. Now the final temperature who is warmer in the problem, Brendan? The metal or the water?
The iron.
The iron's hotter, right. So if I drop this hot iron into cold water, what's going to happen to the temperature of the water? It's going to go up. What's going to happen to the temperature of the hot iron? It's going to go down until they are equal. So the temperature of the water goes up, the temperature of the iron comes down until boom, they're the same. So the final temperature of the water is same as the final temperature of the iron. So there's only one final temperature. And the specific heat of iron we can get from our book, 0.4494 joules per gram degrees Celsius. So the water is gaining heat. The metal is losing heat. And that's the most important thing to solving this problem, Terry, is understanding that the metal is losing heat. So it's negative Q. It is losing. And the water is gaining, so it's positive Q. This is the stem, Victoria, that we will use to solve the problem. Once again, I think of it in terms of dollars. If I'm negative 20, Maggie is positive 20. My sign is negative, her sign is positive. But the number is equal, right? Negative 20, positive 20. So that's why these two things are equal, except that the metal is losing. metal is negative. The hotter thing always loses heat. It's my lunch money. Need it back. Can't have it. Okay. Now we're going to take our equation from the previous problem. And we are going to expand it for each side. So negative Q of metal would be negative mass of metal, iron, minus final temperature, minus initial temperature of iron, times specific heat of iron. The negative sign comes from there, because the metal is losing heat. That'll be equal to mass of water times final temperature of water minus the initial temperature of water times specific heat of water. So in our previous problem, we just had one substance, one equation, really. But here we have two substances. We have the Q on one side and the Q on the other side. Which means we're going to have lots of fun with algebra. So this is where I said at the beginning of the year, we don't do really tough algebra, but the algebra that we do use it. So, let's plug in our numbers. Then we combine these numbers up front. If you know your algebra, both of these get distributed through the parentheses. Not just the 100, both of them. To make it a little bit faster, I will combine these two. And I'll do the same thing over here. And be careful about losing that negative sign. You don't want to lose the negative. Then we will distribute and combine like terms. Now we're running out of time here, so I want to make sure that you know that this is your homework for tonight. This is your homework for tomorrow night. If you feel like you understand this problem well enough, go ahead and get those other ones done. But if you feel like you don't understand it well enough and you need a little bit more explanation, well, we are going to go through this